Hello, and welcome to another edition of Mr. Chappell's Chemistry Screencasts. Today, we're going to learn about significant figures. What you'll learn today is how to count the number of significant figures in a measurement. You'll also learn how to do calculations with significant figures. Now, there are a couple rules for counting significant figures. First, you want to make a box that includes the first and last non-zero number of the measurement. Next, you want to look for a decimal point. Thirdly, if there is no decimal point, only the numbers inside the box are significant figures, and essentially you're done. And finally, 4, if there is a decimal point, also include the zeros to the right of the box as being significant figures. Now, here we have 6 examples, and let's go ahead and do each one in turn. And for the first one, we go ahead and we put a box around the first and last non-zero digits, and we look for the presence of a decimal point. Now, there are no zeros, so there's not much point in finding the decimal point. And so this guy has a total of 4 significant figures. That's all the digits in the box count. For our next one, we include in the box we include the 1 and the 2. And you notice we don't include the 0. There is no decimal point, so this measurement only has 2 significant figures since there is only 2 in the box. For our third measurement, we also put the box around the 1 and 2, but this time you'll notice that there is a decimal point. So according to rule number 4, that means we have to include that 0 as a significant figure. So this measurement has 3 sig figs. For our fourth measurement, we put the box around 4 digits. And there's a decimal point, but there's no zeros outside the box, so everything is going to count. This has 4 significant figures. For our next measurement, we put the box around the 5 and the 4, and there is a decimal point, but you'll notice that none of the zeros are to the right of the box, so that means they don't count. So this measurement only has 2 significant figures. And lastly, we put the box around the 5 and the 2, and you'll notice that there is a decimal point, and there's a 0 to the right of the box, so that 0 has to count. This measurement has a total of 4 significant figures. Now, when we're doing calculations with significant figures, there's 2 rules that we're going to need to follow. One rule is for multiplication and division, and this is the one we'll be applying most often. And the other rule is for addition and subtraction. In each case, the general idea is that your final calculation, your final number, may be no more precise than the measurement that was least precise. Or, put another way, a chain is only as strong as its weakest link. For multiplication and division, the way that we find the weakest link is we look for the measurement that has the fewest number of significant figures. And your final answer may have no more significant figures than the measurement that had the least number of significant figures. For addition and subtraction, we don't look at significant figures, but decimal place. You may have no more places to the right of the decimal point in your final answer than the measurement that has the least number of decimal places to the right of the decimal point. Let's go through a couple of examples. Now, here we have some calculations, and the first order of business is to just simply get the right answer. So if you're viewing this at home, go ahead and calculate these values, and this is what you should get. Now you notice I'm just simply including all the digits that my calculator gives me. I'm not going to be able to report all of those digits because of the rules for significant figures. But your first goal is to simply get the right answer. 4/5 of getting the right answer is just getting the number right. Sig figs is what you want to do after you get the right answer. So let's go ahead and take a look at the first one. And for the first measurement, we only have 3 sig figs. The next one we have 2. The next one we have 4, and for the final one we have only 2. Now what that means is we're only allowed 2 significant figures in our final answer. So we need to put a box down that includes just 2 digits. So I'm allowed to report the 4 and the 0, but not the 8 and any of the 3s. So the final answer is going to be 410. Now you notice I did round up because that 0 is really close to a 1, closer to a 1 than it is a 0 because the next digit's an 8. Okay, for the next value, next measurement, next calculation, we have 2 significant figures and 3 significant figures. That means our final answer may only have 2 significant figures. So again, I've got to have a box that only allows for 2 digits. So the final answer here is 52. Now you notice I round up the 1 to a 2 because that one is closer to a 2 than it is a 1 because the next digit is a 7. For our third example, the first measurement has a 4 and the second measurement has a 2. So that means that we're only allowed 2 significant figures. So I need to put my box around the first 2 non-zero digits. Now notice I'm not putting the box around the zeros, but I'm putting the box around the first 2 non-zero digits. And my final answer is going to be 0.025. And again, I'm rounding up the 4 because the 4 is closer to a 5 than it is a 4. Okay, for our next measurement, you'll notice that it's in scientific notation. Now, scientific notation is kind of easy because if it's written down, it counts as a significant figure. Notice that the exponent never counts. Those would be placeholders if we were to write them out. So the first measurement only has 3, and the second one only has 4. So that means my final answer, I need to have a box that includes 3 digits. So I write down my final answer is 1.48 times 10 to the power of negative 5. Okay, for our next calculation, you'll notice that this is addition. And the rule here is decimal place. In the first measurement, I have several places to the right of the decimal point. But in the second measurement, the 12, I have none. So that means in my final answer, I'm allowed none because the 12 has none. For our last calculation, the first measurement has 2 significant figures, the next 3, the third one has 3, and the fourth one has 2. So I'm only allowed to report a total of 2 significant figures. Now this one ends up being just a little bit more tricky because I'm going to have to round up. And so what I want to do is I want to write the measurement as 1.0 times 10 to the power of 10. Now you notice the decimal place moved because I'm going to round up and the number is actually going to appear a little bit larger. And that's how you do it. It's joke time once again. Hey, did you hear about the police who were called to a daycare where a 3-year-old was resisting arrest?